Hi, today I want to get into soldering up this PCB. This is a general purpose register PCB, and this particular one I'm going to start using as the program counter. It'll replace 6 breadboards in the build. Now, it's two-sided, and there's a lot that has to go into this, and unfortunately, there are some silkscreen markings that I unfortunately missed again. So I want to make sure that I get that cleaned up as well. The order in which I solder this is going to be important because some components are going to be nearly impossible to get to for soldering if other things are already in the way. So let me get out the digital microscope and we'll get right into this. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. While I'm working on soldering, I also want to take a look at some of the things that have gone wrong with the silkscreen here. And the first thing I'm going to work on is this capacitor down here in the bottom left-hand corner, which is the bulk decoupling capacitor. And that's the 47 microfarad capacitor. So I want to get that labeled properly. So on the back silkscreen, put some text. Okay, so that improves the silkscreen on the back for this. Okay, while I'm working on the resistors up here in the corner, I did want to give a bit of an update here on this IC and basically my replacement EEPROM. It's been 17 days since I soldered it up, and it has been about 10 days since I placed it into the circuit and left it there until just today when I pulled it out to take a look at it. And the first thing I want to look at is what is the voltage right now across VCC and ground here on the IC. And I'm hovering right around that dangerous part where I would lose data. So let's plug that in and give that a quick check. Well, and while I don't have anything to compare that to, that does look reasonable to me in that that position there has 1-3 in it, and this position down here has 0F. Well, maybe I do have something I can compare that to. Okay, I'm going to make this a little bit more narrow. 1-3 and 0F, those are in the correct positions. So that looks like it's still holding on pretty strong. Okay, I'm zoomed in here pretty tight on my board, and these are the forceps or tweezers I've been using to try to position all the components on the PCB. And I'm not sure if you can tell, but the challenge here is actually the thickness of the tines. I guess that's the right word, are the tips of the forceps. They actually are so thick that they barely fit in between the components, such as the registers. Well, I have these that I got as well, and I'm not sure if you can tell the difference, but they come down to a pretty fine point here. And this should make things a little bit easier for me to get things positioned, like such as the registers and the LEDs where they're stacked right on top of each other. With any luck here, I should be able to get things organized just a little bit better. I had these sitting in a drawer, I just never pulled them out and looked at them. I'm glad I did, so I'm going to use these going forward. Okay, next up here is to update the back silkscreen associated with the ICs. And so let's hide just about everything else but the back silkscreen. And so I've got 6 ICs that need to be updated here. I'm going to use this as my template, and let's paste that here. There's my pin 1 marking. I want to face the label such that the pin 1 is at the bottom left on every label. And so this is going to be for 74HC541. Center and center, move. I should be able to drop that right on the crosshairs. This one should be 574. So those two are my latches. And I'm sorry again for zooming in and zooming out. It's fun to look at because it's both backwards and upside down. Okay, now C1 has an incorrect footprint, so let's get that cleaned up here. And C1 is right here. Yep, and it's got an LED footprint. So this is what I want. Capacitor. So now if I update, that's got the correct footprint on it now. Next up, I need to put the values of the capacitors on each of the decoupling capacitors for each IC. Each of those are 0.1 microfarad sitting across the power pins of each IC. So let me just drop those in place real quick. Now, this should really take care of the back of the PCB. So once this is all complete with these capacitors, I should be able to flip the board over. And I need to start with the capacitors on that side because I've got an IC that sits right up against one of the capacitors. So I'm going to have to make sure that I get that the capacitor soldered in first. Otherwise, I'll never get to it with soldering iron. Okay, let me start by capturing one of these labels off the back. Let's flip that onto the front, rotate, stick that right about there. So let's take a look at that. That's on the front silk, that's correct. All right, so we'll hide the back silk screen. So this is the capacitor that's going to give me so much trouble. A couple of capacitors over here. Okay. Okay, this first I see over here is a 74HC138. So that's what I want to paste up here. All right, center and center, 74HC138. Then up here on top, I have 74HC193s, and I've got 4 of those. Once again, I want to get it so that it's upright relative to pin 1. Now the remainder of these ICs are 541 line drivers. Okay, now while I'm in here, let me make everything visible again and rerun the design rules check. I'm happy with that. Okay, while I'm working on completing this up in the corner here, here is the completed PCB with the exception of the actual pins. And if I bring this in, what I really want to test here for is, I've got it on diode mode here, but I want to test between VCC and ground and make sure I don't have any shorts, and I don't. My concern here is as I try to test whether or not each of these light up, and you can see all the LEDs light. That's a concern that I can't actually go through and test them all individually now that I've got it all soldered. What I'm going to do is I'm going to bring my backplane in at this point, and we'll work on E today. And I've got some pins over here, and ultimately, there I go saying that word again. But what I'm going to do is I'm going to drop all these pins in here. And these are for the different buses and the control signals and all of that stuff. It gives me pins for everything that needs to go in here. And then if I start lining everything up, this should, in theory, drop right on. It gives me the ability now to solder this all down. Now it's just a matter of doing all the other pins. Okay. That's settled in there pretty darn good. Yeah, I'm quite happy with that. Now I got to figure out how to hook this into the rest of the build and test it. Okay, I've got the build back out, and this is the new program counter that I've just put together. And that is going to replace all of these breadboards here. So, first order of business is to get this pulled out of the build. Power, power, power. This is my main bus input and output. And then this is my address bus 1 down here. And these then are my connections into the control. And I believe, well, I've got power here for my memory module. And I have a clock that I'm picking up here. This one I wasn't prepared for. No, that's a reset. That's tied into reset. So that pulls that much out. My address bus 1 connection is really right here. Address bus 1. So quite literally, these are the connections to make that hook up. And then this little tiny board here can go away. My main bus, I'm going to take these shorter ones out. And I'm recovering some longer ones from what used to be address bus 1 on the breadboards that I just removed. Okay, so here's my least significant bit. And those will go up here into the top. Am I off screen? I'm barely on screen. So these are up here. And the only other connection I have up here is power, which I will use that later. Alright, so now things are getting kind of tight here. Is I need to pull this line down here so I can plug it into E. Let's see if I can slide this over just a little bit. I believe that's good enough there. Unfortunately, I've got some bad glare. We'll have to work on that. Let's see if I can get this hooked back up power-wise. So I remove power from here. So let's hook power back up down here. I think that'll be good enough. I've got VCC on the bottom and ground up on top. So now power will be coming in up here. I'll be able to take power off of here and distribute it to the rest of the build. And I'm going to do the same thing down here. VCC and ground. Now the next thing I need to deal with is my reset. I've got a long line over here. I can't see my god, I put my head in the way here. And this will go in here. So that should handle my reset for me. I'm looking to see if I've got everything hooked up, and I might actually believe I do. I've got main bus attached. I've got power and power. I've got address bus 1. This is still my fetch, which hasn't changed. My R1 resistor here, which will be the next thing to be replaced. Yeah, I think I can plug this in. I do want to do one test before I do. And I want to put this on continuity. And just to double check and make sure, I'm going to test VCC and ground and make sure that I'm not shorted. I'm not. The other call out here is that I've replaced my temporary EEPROM with the normal EEPROM here. The battery's dead, so I am going to have to do some work on that. But I didn't want anyone to call me out on that. So let me get this plugged into power. And if I apply power now, I'm going to make sure I'm in single step here. And while I have power, I don't have any lights on. So that's not necessarily a good thing here. So what's the problem? Let's put power on again. Let's check voltage. There's no voltage there. Which means that I probably have a problem up here with the board. Something was probably designed incorrectly up there, so I gotta take my other power. So now I've got power coming into this rail, and that's gonna backfeed into this board here. And yeah, I've got power. So let's turn this down a little bit slower. I've got a power problem. You can't see that below here, but I do have a power problem where my voltage is reporting low. So let's research that and figure out where that is. It's 4.8 over there. .8 there. So once again, ground. 4.79, 4.78. Up here where it's actually coming in, 4.8. I'll try a capacitor in here just to see if that helps. Maybe I'll pull a couple of them. I'm pulling these off the program counter that I just replaced. Let's get that put in correctly, Adam. Let's see if that doesn't help. No, I'm still showing a reset here. Getting 4.9, so I'm getting better voltage there. It's 4.6 down there. Okay, let's try. 4.87, and down here 4.83. This light is set to come on at 4.86 volts. Kind of makes me wonder. Well, as I go through this, it does appear to be working, even though I've got a power problem. And my jump worked. So let's try some more capacitors. Okay, that has now gone out. Just by adding a couple of extra tie points. I'm going to have some power problems, I believe. So let's reset. And now I believe this is working exactly the way I need it to. This is interesting. That did not work out well. It jumped, but it didn't latch. So my latch is not latching. I'm incrementing, but not latching. All right, what code do I have in here? I believe I don't have a jump in here. That's why it's not jumping, but I will have to figure out this latch. So let me start with, let's pull out the logic probe here. And let me confirm that I've actually got a good latch signal here. And I may not, because I didn't think about this. I've now got LS logic that's driving HC logic over here. So I need to get some pull-ups over here. Let me pause the video here. Let me get that done. Find some pull-up resistors, get those dug out, and then I'll come back and we'll retest this again. Okay, I pulled out my bin that has 1K ohm resistors. And my head's going to get in the way here, so I apologize for that. But I want to drop these in here to make sure that I am actually pulling up each of these signals. Just to make sure that I am overcoming the differences between the TTL signals and the HC signals. And I may need to get a full length lead resistor for this particular location. Let's try, see if I can wiggle this in here. And then the last one I need is that one right there. And that has not changed me getting the end latch signal. So let's pull up the schematic, actually the PCB layout here. All right, and so I've got this highlighted. This is the end latch. So this is 4 pins in, and it goes to, unfortunately, an IC on the back and another IC on the back. Well, let's test this and see if I can actually get the signal here. So this is pin 1, 2, 3, and 4. So yeah, I'm getting the end latch signal here. What else can I test? Well, if I look at this, the end latch on the D-type latch on the register itself actually comes through a via up to the top of the board, and that traces on the top of the board here. So if I can locate those, one is right above the first LED. So if I can find that, I might be able to measure that. So that would be here. And yeah, I don't know if you can see it, but I am getting the end latch. So I am at this point believing I have a display problem. So that's good there as well. So the other one is fully buried on the other side. So the LED, so the signal was making it, I'm assuming, to the input because it's also making it to the AND latch here. So it's making it to these two vias. So I'm good there. I'm assuming it's making it to the input, although it may not. I'll have to double check the input. But then looking at the output, that's the second pin in. So it's the third pin from the top and the second pin from the top on this IC on the back of the PCB. Let me pull that and double check the solder connections, make sure I didn't mess one of those up. It's entirely possible I did. And then we'll come back with the microscope to look at that together. Okay, I'm zoomed in pretty tight here. And the two ICs in question are these two. And this is the one that may or may not have a problem. For example, if I look at this pin here, there's definitely something going on there. And so much fluff, and I am not sure what that is, but this looks like a bent pin to me, which I am not certain how that happened. Yep, that's a bent pin. Certainly not connected to the pad, that's for sure. So let's see what I can do to fix that. That may be a challenge. And what's important is that's not even the pin that's in question. This is the pin that's in question, and that looks like it may not be soldered right either. All right, so let's see if we can get this fitted right. Okay, that looks good. That's just not taking to the pad, is it? Okay, I've still got my microscope out here to the side. Let's get this reinserted. And then do power again. And I am now getting my latch. So that is a good thing. That problem is solved. Okay, I have now reprogrammed these two program EEPROMs with the code from video 51, which is the Half-Larsen jump test. So we should be able to get this powered up, and we'll put it in single step mode and reset that. And under here, this is working just fine. And as this gets to the most significant bit here, there should be a jump to take it back to set this least significant bit. And there's the, I believe, pre-jump. Maybe that is the jump, I don't recall. Yeah, it's already jumped back to 0 over here. But it did not actually latch. Alright, so to help me test, what I've done is I have created a small program which literally has a couple of no-ops in it and then a jump to the highest address space. The purpose of that is to make sure that I get all of the LEDs turned on and the jump itself actually takes place. If not, it will just continue to execute no-ops until it loops back around. I've written that to the program EEPROM, and now I just want to plug it in and execute a test. Okay, let's plug it in and reset. Now address 0 should have a no-op in it, and that's now up here. Address 1, also a no-op in it. Address 2 should have the actual jump instruction, and then address 3 should have the jump target. So there's my jump instruction up here, buried under all these ribbon cables. Here's my jump target here, and I'm expecting this to show up with all the lights turned on here. And that does work. So now the next instruction should be a no-op, actually from this high order address, which is coming across like that. Oh, that's interesting. So it looks like all of these incremented back to 0 properly. So my increment here worked properly. But my increment coming off of this second nibble I see to the count up here did not happen. And so there's something that is not right there. Next clock, and now it picked it up. So do I have a delay problem? Am I latching too quickly? Could the problem actually be over here in my control logic? That's what I'm considering here. In other words, I'm not having a problem here, but rather I'm having a problem here where my AND latch signal coming off of my control logic is happening too quickly, and I've got a bit of a race condition happening. All right, let's think about this logically. Let's first figure out if the counters have the right value on them. And I need to bring up the pin diagram here. So QA is on pin 3. So that does have the right value. That does have the right value. QB is on pin 2. Correct. Correct. QC is on pin 6. That's correct. That's correct. Pin 7 is QD. So all of those are good. So that tells me that at least I'm loading the correct values. Now, what am I latching? I'm latching, unfortunately, those latches are on the opposite side again. Where is my address bus 1? There it is. So address bus 1 is outputting high. So that tells me that the upper latch is not latching properly. Time to pull it out and take a look at the back of it again. Okay, I'm on the top corner of the board here. This is the back side. And these two ICs in particular take care of the latching. And this is the upper byte, and this one over here is the lower byte. And I'm going to reflow all of these joints just to make sure that everything is good. I can't see any floating pins, if you will. But on the other hand, I've got some really horrible looking solder joints. So I want to reflow them all and just see if I can make sure that that's all working correctly. I may be back to a timing problem. Let me get these reflowed. Okay, I'm not sure I expect much of a change in this, but let's give it a shot anyway. Okay, so again, that was exactly the way I anticipated, and again, that does not work. Okay, I went off on a wrong tangent here trying to trace down latch signals and the timing of the latch and what's being asserted to the bus and when, and that ended up being an incorrect direction. So I want to go back and take a look at timing again, because the more I think about it, the more I believe that the propagation delay for me to get from this first nibble of the increment all the way up to the last nibble of the increment is probably a little bit longer than I'm used to, and I probably need to take a good hard look at that. And so I'm just going to build in a massive delay here on this signal and see if that actually addresses the problem. This is a 74 LSO4. I don't have it labeled. I want to go through and basically put in 6 inverters and confirm that that either is or is not my problem. And so my output for this signal now, which is this line, is going to come from there. And then the input here. And basically I'm just going to chain all 6 of these inverters together. Now I expect to have to reset this after that. It did not, but I will reset. My end latches are happening as they should, and that now is working. Let's let that run. I got to reset back down. All right, I'm happy with that. And this PCB is, well, as working as best as I can determine at this point in time anyway. Well, I'm glad to have that working. Now, I did leave a number of issues on the table. I do have a power problem with the backplane that I've got to sort my way through. There is still something going on with that power supervisor, so there's a voltage drop in there that I do have to solve. I think I just patched it up by interconnecting power and ground a little bit better. And then, of course, I've got the timing problem that I've got to deal with. So I will work on those. The next video I have slated is to talk about ALU add and how I plan on designing that. And I think on the heels of this discovery with the propagation delay, I think it's important to probably get into that ALU add because my plans there may change as a result of my discoveries today. So that'll be the next video, and then after that video I will work on getting the R1 register converted over to the new PCB format. Now, there's a lot of work that goes into putting one of those PCBs together. It took more than 3 hours of soldering just to pull one of those together, and I don't want to subject you to all of that solder time. So what I'm likely to do is solder it up off camera and then test it on camera. That way, I don't have to subject you to the same thing over and over and over again. The challenge then becomes it changes the cadence of the video release. So it will take a little bit longer for me to pull a video together now that I have so much work to do off camera. And so I apologize for that. I was hoping to do 2 videos a week, but hopefully something a little bit longer once a week, or possibly even every other week. Leave comments, let me know what your thoughts are on that. Thank you. We'll see you soon.